This week on FX Guide TV.
We're in LA at SIGGRAPH 2015, where we're looking not only at the new trends and emerging tech, but also speaking to the head of R&D research from Weta.
This and more coming up next.
Hello and welcome to FX Guide TV. I'm Angie. This week we're reporting from LA from SIGGRAPH 2015. And FX Guide has been there covering all the latest computer graphics, research and presentations from visual effects studios. There's always incredible stuff on show, from hardcore rendering algorithms to the latest in character animation, as the guys found out.
Thanks, Angie. That's right. We're back here at the Los Angeles Convention Center for SIGGRAPH 2015, and we've already seen quite a few things. We went to a Pixar talk.
That was great, yeah.
It was really a good talk about, it was called Animators Daydream, and they explained how they're developing new tools inside Pixar to help the animators. And it was really cool stuff because it really made you understand how the importance of working closely between the software developers and the artists, and to make sure the tools actually get used. And so it was a really great talk. It was really good. And then we went to the papers fast forward already, which is the 30-second of each clip.
There's like 180 papers, I think, that going through at 30 seconds a pace, so it's always good.
Yeah, and I'm reminded that emerging technologies is always one of my favorite things here, and I remember hearing the word haptic first here when we did a piece, John and I did a piece, I think, we would put your hand in something and you got feedback, and now, of course, with the Apple Watch, wearing it, and you get force feedback when you touch the watch, so you often see stuff there in emerging tech that becomes widespread pretty soon.
You'll be glad to know there's more of that. In fact, now you can put your hand in a virtual cube and knock something off in a virtual cube that might be on the other side of the planet. But for me, one of the really interesting things is the work that ICT's done in producing the holographic experience. So basically, imagine 200 projectors shooting at a screen, and it allows you to see somebody in the round. But more than that, actually they have a native language system, so I can actually ask questions of, in this case, a Holocaust survivor that was filmed. And so as I ask the questions, they naturally respond to those questions and can answer. And it's really quite a moving experience to be talking to someone. In fact, a little confronting, actually. They were suggesting some of the questions that I might ask, and I just didn't feel comfortable asking a hologram those questions. But the other thing, of course, that's really big here at SIGGRAPH is virtual reality. There's an enormous amount of VR stuff, both inside emerging tech and outside in an area there's a VR experience. And John, of course, we've been doing a lot of work with VR lately, both inside PhD. We had a course last term and, of course, another course this term.
Yeah, I was actually just sitting with Scott Squires at a presentation with Greg Downing from X-Res, got in the middle on that help video, and it was standing remotely. They couldn't actually fit enough people in the room. They needed bigger room for this. So that's how popular the interest is in VR. But I have to say, SIGGRAPH actually, or things associated with SIGGRAPH, actually start before the actual conference and the weekend before. And on Saturday, there are a couple of great conferences. I actually happened to attend the High Computing Graphics conference, really hardcore, serious tech regarding graphics and rendering and so forth. And I actually heard a talk related to VR with Warren Hunt, who's an Oculus researcher, talking about less of the tech part, but actually future tech and what he hoped that the people in graphics could do for solving some of the problems. And a lot of that has to relate with resolution in the displays and how we can get that really high data, high resolution that we need to provide a real believable VR experience. He feels some of that is in the 2 to 3 year period away, and of course more of it's further 5 years away. But while I was at that conference, you were actually at DigiPro.
It's just a characteristic of SIGGRAPH, isn't it? Like, you can never actually go to everything you want to go to, and at any time there's something really interesting, there's another thing that's on that's almost as interesting. In my case, I was at DigiPro. Now, FX Guide's been supporting DigiPro for some time. DigiPro had a lot of great sessions. We've written up some of that, of course, on the site with our regular coverage here from SIGGRAPH, but we also managed to sit down with the keynote speaker, Luca, who's head of R&D research in rendering. Luca gave the keynote address, and about 10 minutes after he finished that keynote, we got to sit down with him to discuss some of the principles of that keynote discussion and some of the future aspects, including actually the software development in the rendering team. Luca, thanks so much for joining us. Really appreciate it. Thank you. I seem to end up at conferences with you all over the world, like we were in FMX not that long ago.
It's been a very busy summer, yes, absolutely.
So you've just given the keynote address here at DigiPro, and in fact, Weta's a big supporter of DigiPro, isn't it?
Yes, we've been coming to DigiPro since the first year. We had a paper on the first year.
Yeah,
here
in fact, I think Joe gave the keynote on the first year that you gave.
Yes.
And I think he actually spoke about one of the things that you showed in your speech, which was then the sequence with the horses and the deep shadows for moving the light, which was in what?
Yes, in Abraham Lincoln Vampire Hunter.
Right, which was a film remarkable mostly for the work that you did on the shadows and the horses. It was technically, I mean, technically speaking, it was a really innovative approach to being able to relight and move those lights volumetrically through the dust while using deep compositing techniques.
Yes, it was a case of being able to leverage an algorithm and, in some sense, a lucky situation to just make it fit very well for that specific kind of shot. It works well because the light is very small, because the sun is very low, and then being able to integrate that into Nuke's deep compositing pipeline has been extremely useful.
So the work that you were doing then was in, I'm going to say, RenderMan?
The rest of the renderer was RenderMan, yes.
Yes. And then had
this
you
little thing was a custom renderer built just for that.
Yeah. And then had you implemented Panarray at that stage?
Absolutely,
at Weta?
yes.
Right, because that was first on Avatar? Right.
It was Avatar and then Tintin, the Shadows extension, and then the other productions.
Right. And then we first saw Manuka appearing in, I'm going to say, Apes, right? There was like 5 or 6 shots? Yeah.
Yes.
And of course, then...
Hobbit 3.
Hobbit, yeah. So that transition is obviously indicative of the major commitment that Weta has to R&D and the rendering R&D that your team basically are on an ongoing effort with.
Yes, we have been doing rendering research for a long time, and the more we've done it, we've found satisfaction into getting deeper and deeper into these problems. And so coming out of Avatar, that was the first major directly rendering related project with the Pantaray. And then, just gaining confidence on all the successes of our subsurface work, we just kept going and going bigger. Was great.
Was Manuka ever meant to be as big as Manuka was? Because, I mean, writing a full renderer at the level that is, with the efficiencies that you managed to find, was it planned to be that at the outset?
We tried. I mean, it would have been a failed point, right? We wanted to see if we could do it, and then we did research on how to improve it, so that it would meet our performance points. But it was an experiment. We wanted to understand whether a project of this magnitude could be carried out, and trying new algorithms and trying to do new research in the domain of path tracing, just all the new things that were happening. If you remember, at the time, Arnold had almost just started being publicly available outside of Sony. So it was, it was.
Yeah, of course, it had several years inside Sony, but it only
exactly.
Yeah. And was only available to those that asked nicely. So, is there any aspect of Manuka that really, looking back now, you think has sort of worked out better than you expected? Was there anything that kind of surprised you by how well it worked?
We have done some great engineering on the renderer. It's relatively very easy to fix. A renderer of this size is always very hard to fix, right? You have a million lines of code, it's a problem when bugs come about. And I have to say, compared to the scale of other projects I've been involved with, this is by far the easiest we've had in terms of being able to effectively address bugs. Also, the other cool thing, it's always been a project meant to do research on rendering algorithms. And so implementation of new things is the thing we do all the time. And it's lovely just to be able to experiment with new stuff.
You were discussing today, I guess, your view of the place we are in the sort of the pantheon, I guess, of a lot of research that's happened over, many generations. It's not just a tiny snapshot of what's happened in the last 18 months. You were really trying to give us some perspective on the problem. And I want to swing around to that because I'm really interested in, especially in some of the points you made at the end about forward-looking. But
yes.
But you were referencing right back to people from eras way before there was even computers.
Absolutely.
Why did you want to go there? What was the sort of to sort of summarize, what was the sort of central themes that you were pulling from for that? Because they're obviously personal themes for you.
Some of these themes are very personal, and some of this is just, everything changed. When I was a kid, I had this thing for the structure of matter and atoms, and I just, as much as I had a little projector, I would listen to, records as everybody else, but also had a couple books, very, very simple for kids, books about atoms and electrons and things, and I was just fascinated with this stuff. And then growing up, I became a mathematician, and so the origin of the mathematics we do today, where the physics that we do today comes from, it all came about together at the early 1900s, so we were saying. Together with cinema, to a point, together with computers. Computers are a little bit later, but just about 20 years later than that.
We often discuss the artistry and the science of work that somewhere like Weta does. And so for a second, if I can, because I think you know me well enough that we've obviously looked at the artistry of Weta. I just want to look inside the science for a second, knowing that, of course, you're servicing the art. Inside that science, you mentioned physics and maths.
Yes.
But as you moved forward, there's also a huge engineering component, which you didn't seem to hit on as much today.
Well, there's engineering, there is invention, as I was saying during the talk, and there is computer science. I believe that computer science is a science, a real one. It's not. It's separate from engineering. It's not just about the practicalities of having systems working. It's about understanding at a conceptual level how a computational model works, which is a little bit the end of the talk, right?
Yeah.
If we change the computational model, is it really changing? Is the computer science we understand today going to be relevant in 10 years or something? And is 10 years enough to bridge the gap? Because if you change the machine and you can't program it, you have a problem.
All right, well, let me look at it from a slightly different point of view. Like, Weta has a team that wants to do some R&D.
Yes.
I mean, if you're doing some R&D, and let's leave Weta out of it for a second, if I'm doing R&D at a university, or it's mainly research, nobody cares what I'm coding in. I'm not really concerned about how precise the code is, because I'm just experimenting and looking at stuff, right?
Absolutely.
But if I swing to the other end of R&D to the development, and I'm at a major company like SolidAngle or anybody else, I'm very concerned about updating, documentation, the software engineering aspects of what's going on.
Yes.
Did you always sort of, with your team, adopt a kind of a productization engineering slant, or did you start with let's experiment, I don't care where you go or what you use? Because they're two quite different things inside that space.
We try our best to keep a healthy balance of both. So when we do experiments, I always urge the team and myself. I mean, it requires a lot of discipline, arguably. And so I try to help with providing some from outside. But there is this notion of never having code that is so dirty it could never enter production, especially because very often the tests we make and that we think would last a week actually stick and last 5 years. And so it does happen that you will have to maintain anything you write and as promised. It's not the way you would prefer to do it, but sometimes it's just practical to do it that way.
Well, you had a great graphic up of your team, which was about, I'm going to say, a dozen people, all looking very happy.
Yes.
And then I think you were saying that you had a visiting, I mean, I know some of the people that have visited you, but you were saying something like 5 a year almost, was that right?
Just about, yes.
And they would come for sometimes a month or two at a time, right?
3 to 6, depending on the person, yes.
Okay, so that's right there a problem, right? Because somebody comes to work in your team and does some great stuff. They're there for 6 months. That's long enough to contribute, but not long enough to hang around to fix anything that comes up later.
Absolutely. We have, it's not quite a technology transfer program, but we certainly, work together with the visitors to make sure that, the code that we then decide to retain is maintainable and just works in the middle of our system. I have to say, of course, being a group of responsible adults, it has been very easy to do so. We never had any accidents or strange stories.
So I'm just curious about this, I guess while I'm on this engineering topic. I mean, for example, do you do agile software development? Do you do scrums? I mean, how do you actually run this project?
So we run a lightweight version of Agile.
Yep.
We rely on continuous integration a lot. And the way we do continuous integration is that we release the renderer maybe 3 or 4 times a week. And almost anybody in production is able to pick it up on the day.
So you actually have like scrum leaders and sprints. It sounds like very much you're maintaining that kind of a style.
We have stand-ups. So we do daily stand-ups of about 5 to 12 minutes, depending on how complicated the last couple of days have been. And yes, pretty much I run a relatively liberal game. I have a lot of trust in the people that work in the group. So I very rarely tell them the specifics of what to do. It's all about, problem domains. And that's the kind of leadership that I prefer to exercise. And then they just report all the time about what's happening in their domain. Sometimes we discuss what's happening in detail. Sometimes just things, nod along and progress.
So in a software development
it's a very lightweight, agile thing.
Yeah, no, it does sound like it. But then if that's like, this is my biggest problem this week and somebody offers me help at that kind of scrum level,
Absolutely.
You've also got this other level that you need to operate at, which is inherently what is a good architectural model for us to go down. I mean, GPU, CPU, like bigger picture issues about the structure and nature of the memory requirements at a very philosophical level, because you were touching on that as well today.
Yes, and there's so certainly there's we forgot to mention contacts with the client. We meet with our clients daily, depending on the various productions. That could be weekly if they're more relaxed about what's going on. But we're available every day for an hour.
When you say clients, you mean the client and the many people in the client, right?
Well, yeah, I mean, we're part of the studio, so
Yeah.
there's every single show has a VFX supervisor
Right,
that
I
we
see.
consider our client.
So you sort of really consider them as separate entities, because I guess they've got separate requirements.
Yes, I mean, some are about scale, some are about leaves, some are about fur, some are about, it's all sorts of things. Water, droplets.
Okay,
Stuff.
but to get back to that, that's still at that level, right? Which I think we'd be comfortable with.
Absolutely.
But I would be coming to you if I was a supervisor. I would love that I was a supervisor. Imagine I was a supervisor at Weta. I'd be coming to you, but I wouldn't be asking you about, hey, do you think that this overall kind of approach to the way computers are going to develop over the next 5 to 10 years is relevant? I'd be like, I need to get these shots done. How do I
Absolutely.
do the fur?
Absolutely. So in terms of the longer picture view, we maintain a 1-year plan and a 5-year plan, and we try to keep them as up to date as possible. Of course, the 5-year plan is a relatively fuzzy notion, right? It's not quite as detailed. It doesn't have action items on it,
Sure.
for example. But it's about exactly understanding memory scaling, understanding what can be the budget in dollars compared to the budget in terabytes of hard drive or RAM or what have you. How many cores do you expect to have in the next generation machines that we're going to buy? Do we scale linearly to that kind of core? So for example, we always own machines in the team that are a fair bit bigger than what's in the render farm, because we need to check that when the investment is made, it will actually pay off. And we're on
So
big
how do you
eyes.
keep that perspective? I mean, I'm sure people turn up to you with roadmaps, but that's like a product thing. Like I want to, sell you on our kind of technology. But you need to have this kind of view of, I think that there's going to be bottlenecks in memory access, in GPUs if we go too far down this path. Because your scale of a Weta shot, I mean, like let's look back for a second. When you were doing Panerai, it was because
Yes.
Avatar was just so big, right?
Yeah.
And I mean, it was just off the dial big.
Absolutely.
And that's past tense. So your scale is not the same scale that almost everybody else has. So while you're obviously very important, you don't represent the majority of users. So a roadmap for the majority of users may not be relevant to your needs.
That is certainly a problem we have had with some of our vendors. And yes, we understand that, right? We are a fairly unique customer, and we have special needs especially in terms of scale out of scene size.
Yeah.
That is our typical blocking point. And the renderer as well was always designed to be scaling very big, designed to do, whatever, the next avatar.
So in addition to the DigiPros and the SIGGRAPHs, are you having to spend a component of your time, just basically at general computer conferences trying to understand the nature of, how do you sort of stay in the loop?
We're doing this more and more, looking at general computing papers, new and old, because, again, as we were saying today, it seems that the computer of the future may actually share some traits with certain theoretical architectures of the past. And so we actually are surveying quite carefully very old literature about strange machines that did not quite get anywhere, and see what could be learned from those. But yes, reading papers is something that, as a team, we do all the time. It's not just me. It's a very distributed effort.
Sure, but in your paper, in your talk today, you were presenting a fairly pessimistic view of our ability to keep living in the wonderful world of, I think you called Moore's Law, basically.
Absolutely.
You really were saying that you thought that's going to stop being as strong a factor in us getting a free lunch moving forward as soon as, I think you said about 5 years, didn't you?
Yes, so there's two things. In terms of acceleration of compute, clock rate, that stopped years ago.
Yep.
And we've been unable to, get much past. Different vendors of silicon have different maximum speeds. Intel has one, Oracle has one, IBM has one. They're nearby, but some are higher than others. But nobody's saying that if there are out processors that could do 6 gigahertz, nobody's thinking that there will be a 12 gigahertz processor anytime soon. It's understood that more or less.
We stop
that's
talking
the
about
speed.
gigahertz and start talking about cores.
Exactly. Core count is nearing the same end. There will be a limit to how many cores you can put on a die and build a package from it, a processor, a multi-core processor.
But it's also access from those cores to memory, right?
Exactly. And there is certainly a trade-off in the width of the bandwidth to your storage that is complicated. Now, people are doing this thing called through silicon vias. That means that they can put the RAM physically on top of the processor and get away without the copper that I was mentioning during the talk, so that the bandwidth to memory is less of a problem. But it's still not completely clear that that is a solution as opposed to something, a device that will let us survive the next 5 to 10 years. There is a time in the 5 to 10 years outscale in which computing will probably
It would also
change a
seem
lot.
like the layering is a terrifically brilliant idea, but in of itself won't continue to give us every 18 months sort of double the improvement. It's like a brilliant idea that itself won't have like legs for...
We're very good at doing small things. Graphene is another technology that has exactly the same step, right? We're starting with graphene, where silicon was maybe 10 or 15 years ago.
Right.
So we might get 10 years out of graphene in terms of shrink and just computation improve, but it's completely unclear that there are 50 years of better graphene that we can make. And stacking is the same thing. You cannot make stack. You will not make stacks thicker than a certain amount just because it physically makes little sense. You're not going to have towers of silicon.
Yeah. Do we algorithmically have room to move? Have we gotten sort of more casual with our programming because we've had this, buffer of everything getting faster underneath us? Or are the algorithms fairly tight already? We got room to gain there?
So I always try to run in the group a game that is fairly tight in terms of slack that we leave around. And the reason is purely a survival kind of instinct. If you have a million lines of code, finding points that could be useful for optimization is going to be very hard, because the chances of 3 or 4 points interacting together to give you the actual speed up you're after are far too high. And so we try to be very deliberate in keeping the code, relatively speaking, as optimal as possible, and just leaving around comments and just documentation as to what we think could be improved and by how much. What I was saying about using the back of an envelope, we try to know as much as possible. We always try to figure out what we're leaving on the ground and why and where.
Yeah, I really got the impression from your talk that you weren't saying to your team, don't worry about it. You were discussing this idea of sweating the small stuff.
Right.
And you actually like to get your house in order and not just plow ahead and assume that it doesn't matter, it seems.
Absolutely. I very strongly believe it always matters. And the other thing is, writing an algorithm that is very suboptimal or about as optimal as I can in the same amount of time will only take you to a better place, and by definition takes the same amount of time. There's a lot you can do to get an algorithm working clean and decent, as opposed to just the first thing you would code.
So I was talking to somebody and I said I was going to be interviewing you. They said, I'll have a look at what is on his calendar, because whatever Luke is interested in at SIGGRAPH is probably worth attending. So let me ask you the question on the record. There are some papers and stuff, just changing the subject, that are going to be delivered here now. We're about to start the show. Is there some stuff that's caught your eye that you think is going to be interesting?
Unfortunately, this year I have, as you were saying, I've had a very busy summer preparing all these talks. And so I'm going to have to fess up that my SIGGRAPH plans are not quite as solid as they usually are.
And in Weta's position, is Weta presenting technically here? Because you're a big supporter of DigiPro, and I imagine...
Yes, we are, absolutely. Weta has, so we have 2 papers that discuss the renderer. Two courses that discuss the renderer. One is a part of the course on physically based shading, and one is part of the course of production path tracing. And so we just cut the renderer about in half and discuss it separately as these 2 events. These are on Wednesday and Thursday.
Right. I have to say that, just bringing it back to where we started, the thing I like most about what's happened in rendering lately is that we're getting back to these physically plausible models, these physically plausible shaders and stuff. And so what we're seeing is related to that original physics, in the sense that when somebody comes up now with a value that's, say, 0.5 for something, it's a 50% of the energy that's being returned. And so we're less in a world now where you just have to use 50 because that's the number that seems to work. And that knowledge is really specific to this version of the software, and the next version or the next software vendor will just have different magic numbers. And we can start to understand what we're doing a bit more in what's actually happening with light, which of course is the physics and optics that you started your discussion on.
Yes, we have been liking a lot and getting that into the practice of Weta, just this idea of having parameters in real world or physics space, and just trying to teach Look development people and enlighten people about the fact that certain ranges are just awkward, and sometimes you have small numbers to deal with, and sometimes you have very big numbers to deal with. And that's just a fact of life. We distribute tables about what normal ranges are, but we try and leave the interfaces in the natural units for the specific domain. And that, makes it easy if you find research on a certain hair or, skin or something. We try to make it as easy as possible to plug the numbers in and try and get a reasonable result out of it.
Yeah. And I guess the other really terrific thing about Weta, and you're one of like a really small number of companies that have I'm going to say a combination of really good management, really good artists, and luck that you can plan beyond the end of your nose. Like there's a real sense that when you're solving a problem, you're not trying to solve it for whatever the shot we have to get out on Thursday, but then we're going to have better eyes for the next X number of projects moving forward.
We try, and I have to say we have excellent direction from Joe and the supervisors about where to stop when we do that, because as scientists it's easy to get carried away with the last 0.5%, and they're like, look, for this show this is a good level. We're keeping this, and we're continuing this research in 6 months for the next show, or for hair is another thing, right? We would like to address this aspect this year. There's a lot of dialogue about that, and
which I guess also falls into that point we were making before about how you structure your software, knowing that you're not just getting a hack to get it out, but it's something that's a good building block to continue and build on after that.
Yes, absolutely. And don't get me wrong, we understand that making movies is an inherently somewhat dirty, messy business, and so we support that very deliberately. It's not that it's not hackable, it's just that we try to keep it clean so that it's clear what is scientifically sound and what is a hack. And then some things we keep, although they're not as sound as others. But that's how you play the game.
Well, I really enjoyed your talk today, and thanks so much for taking time to talk to us.
Absolutely, my pleasure.
Well, thanks for that, Mike, and appreciate you doing that because, as I mentioned, I couldn't get to DigiPro, so I'll be checking out that app when I get back at the end of this trip. Before we close out, just want to mention that we have a special SIGGRAPH $99 special over at fxphd.com. It's designed for those of you who have not been a member of FXPhD in the past. And for $99, you get one course, you get access to background fundamentals, which this term is actually a series of interviews with visual effects supervisors around the world. You get access to our full suite of VPN software, as well as access to the forums where you can discuss the course material with your prof and other members. It's really a great way for you to affordably check out what's going on at fxphd.com, and you can find out why many of our members return term after term after term. So check out fxphd.com for more details about the special offer.
That's great. That's a great way for people to check things out, and I've had a lot of people ask about something like that in the past. Yeah. I'm sure you guys have too. So that's great. And over on FX Guide, don't forget to keep checking back throughout the week as we continue our coverage here from SIGGRAPH and update as we go along. So thanks for watching, and back to you, Angie.
Great job, guys. It's always a lot of work putting together our coverage for conferences like SIGGRAPH, and that's why we really appreciate the support of viewers like you and our FX Guide Insider members. If you'd like to be a part of FX Guide, then click on the FX Insider link on the homepage. Thanks so much, and until next time, see ya. For more industry news, in-depth features, podcasts and forums, check out fxguide.com. And for visual effects training, check out fxphd.com.